So this is the second topic, which is magnetism. The block 4 we are discussing electricity and magnetism. First, starting with the origin of the magnetic field, why there is a magnetic field, or why the material behave like a magnet, is because everything consists of atoms. Okay, what is the origin of the magnetic field? Origin of the magnetic field is a moving charges. Whenever the charges are moving, this will always produce magnetic field. So when the charges are moving, there is a magnetic field. So everything consists of atom, as we know, the structure, the basic structure of atom. The nucleus is there. Inside the nucleus, we have neutron and protons. And around the nucleus, electrons are there. So this is a simple structure of an atom. Electrons are revolving around the nucleus. Protons are also moving within the nucleus. So the movement of electron and movement of this proton, because these are the charged particles, so whenever the charged particle move, what will happen? The atom will produce magnetic field due to movement of electrons and protons. So the atom will behave like a magnet known as domain. So what happened? As we know, an atom consists of neutron. An atom consists of a nucleus, the central part, the core, which having a neutron and proton, and around the nucleus, electrons are revolving. So due to this movement of the charged particle, what will happen? This whole atom will behave like a magnet, and this atom is behaving like a magnet. What we call this atom which is behaving like a magnet, we call that atom as domain. So according to this theory, because everything is made up of atoms, so according to this theory, everything should behave like a magnet, but in practical or in reality, everything is not behaving like a magnet. There are certain materials which behave like a magnet. Not all materials
Sir,
behave. Yes,
sir, all atoms are domains.
all atoms are domain.
Okay.
So what happened, as atoms consist of neutron, proton, electron, proton are also moving within the nucleus, electrons are moving. So it create a magnetic field, and it means the atom behave like a magnet, and this atom is known as a domain. So every material is made up of atoms. So it means every material consists of domain. But there are certain materials we find them as a magnetic, and not all. Like example, if you take a plastic, you take aluminum, copper, these are not a magnetic material, means they are not affected by magnetic field. But if you take iron, steel, nickel, and cobalt, you will find they are affected by magnetic field. So what is the reason why some of the elements of some of the materials, some of the substances behave like a magnet and other materials does not behave like a magnet? The reason is that is a arrangement of alignment of the or alignment of the domain. So materials which are behaving like a magnet, their domains are aligned, arranged. So when domains are arranged, domains are aligned, that material will behave like a magnet, or it will be a magnetic material. Magnetic material means it is affected by magnetic field. So it is a magnetic material. What does it mean? It is affected by the magnetic field and its domains are aligned. But why some of the materials are not behaving like a magnet, or why the materials are not affected by a magnetic field? Because they have domains, but the domains are random. They're not aligned. So if domains are random, that material will be a non-magnetic material. Because the domains are not aligned or domains are random. Domain here means the atom which is producing a magnetic field. So here they cancel out, and magnetic materials are also known as ferrous. Because why specifically ferrous? Because it was believed that iron was a magnetic material, but now there are more, like nickel is there, cobalt is also there, a magnetic material. But it was believed that only iron is a magnetic material. So iron was a so we called that as ferrous material. Material which behave like a magnet or can be magnetized, and material which cannot behave like a magnet or cannot be magnetized, we call them as non-ferrous material. It's derived from iron, ferrum or ferric, the name of iron. So it's because it was believed that iron was a magnetic material, but there are other elements now which are magnetic. So it is used according to that reference, ferrous and non-ferrous. Magnetic, yeah, magnetic material means in which the domains are aligned or arranged. It contains domains or atoms which are magnets and they're aligned. We call them as magnetic material. Then for a magnetic material, there are two regions where the magnetic field is much stronger than any other part. Like this is a magnetic material. When we find the strength of the magnetic field, we find there are two regions where the magnetic field strength is much stronger than any other part. So the location where the magnetic field is much stronger than any other part in the material, this place is known as the pole. So for every magnet, there are always two poles. Pole means the region, the place where the magnetic field is stronger compared to any other part within the material. And the magnetic materials always consist of two regions where the magnetic field is stronger than any other part. Two poles. So if one of them is known as the north pole, then the other is known as the south pole. So is it clear the concept of the magnetic material, why some materials are magnetic and some are not magnetic, and what is the meaning of the pole? The meaning of the pole here refers to it is a region where the magnetic field strength is much higher or stronger compared to any other part. And there are always two parts within the magnet where the magnetic field strength is much stronger, and we call them as a pole. If one is called a north pole, the other one is known as the south pole. So this is an introduction of magnetic field and magnetic materials. I want you to copy this part.
Sir, so that means for magnetic materials, electrons move in one direction?
No, not electron move in one direction. What happened? It consists of neutron, proton, and electrons. So as they spin, protons are also spinning and moving within the nucleus. Electrons are also spinning and within the nucleus, around the nucleus. So they produce a magnetic field. So example, this is a direction in which this atom produce a magnetic field. So other atoms produce the same direction magnetic field. So we call domains are aligned. Arrangement is same. The particles are always moving anti-clockwise. They are moving the
Yeah,
spin.
got it, sir.
So, but the idea is that the alignment is there between the atoms, so they produce magnetic field in the same direction, which result in alignment of a domain, and the material will behave like a magnet. We call that as a magnetic material or a ferrous material. If a material does not have domains are there, but if domains are not aligned, it means the material will not behave like a magnet, and we call that as a non-magnetic or a non-ferrous material. Example of magnetic materials such as iron, steel, nickel, and cobalt. Example of non-magnetic material such as copper. Copper is a metal, but it's a non-magnetic. Aluminium, wood, plastic, and rubber. These are non-magnetic material, means does not behave like a magnet. They have domains, but their domains are not aligned. You're done, finished writing this? Because this part related to domains and the poles is not there, direct explanations are there in this presentation. That's why I want you to copy. So when we have a magnetic material in which there are domains and domains are arranged or aligned. Domains here refers to atoms, but their movement, spin of the particle is in the same direction, they produce the same magnetic field. So if one side we are saying a north pole, if one side I'm saying it's a north pole, then the other side it will be a south pole, the region where the magnetic field is stronger compared to any other part in the magnet. So we have a north pole and we have south pole. But what happens if I place any magnetic material? Like example, I have a magnet in which the domains are aligned and there's a piece of iron placed, an iron nail is there, or there's a steel object nearby this magnet. So what happens? They are attracted towards the magnet. So the space, the region around which the magnet can exert force on the other magnetic material, that's called magnetic field. The space around the magnet where the other magnetic material can experience force, that's called magnetic field. And the direction of the magnetic field is always from north to south. This is the direction of the magnetic field. It is always pointing out from north and going into south. This is a simple sketch of magnetic field around a bar magnet. There's an experiment also. We can use this experiment to identify what is the direction of a magnetic field. We'll discuss that experiment as well. So what pattern we will observe around a bar magnet? This is called a bar magnet. A bar is there, which is made up of steel or a permanent magnetic material. So we observe that the magnetic field is out from north and into south. So what are the properties of the magnets? Magnets always have two poles. One is called a north, the other one is known as south. A magnet attracts other magnetic materials such as nickel, cobalt, steel. Like poles of a magnet, like identical poles are there. So like poles will repel, push each other. If there are unlike poles like north and south, they will attract each other. And around the magnet, there are magnetic field lines. And our assumption, this is our assumption, they're starting from north and ending till south. So whenever we show a magnetic field pattern, you can see the field lines starting from north and into south. And this is a region, you can see there are more field lines than any other part. So it means this region is stronger magnetic field. So we call them as pole. If one is north pole, the other one is known as the south pole. Any doubt till now related to this part, magnetic field pattern?
So can you explain one more time?
Which part?
The magnetic field.
The magnetic field means the region or the space where the magnet can attract the other magnetic materials such as nickel, cobalt, iron, steel. That region is known as magnetic field. That space is simply known as magnetic field. So example, if I place a piece of iron here, it is attracted. If I place a steel object, attracted. Nickel object, attracted. Cobalt, attracted. So they are attracted. So we call this space as a magnetic field. But how we draw this space, how we represent this space? So we draw the field lines and we draw the field lines from north to south. The direction of the field lines is from north to south.
Does north and south make any difference in the attraction?
North and south does not make difference to the attraction because I told you both region have the same strength. Like example, if I place an object 2 centimeter away from north pole and another object 2 centimeter away from south pole, if object is having a same distance from the pole, it will experience the same attraction. There are two regions always within the magnet where the magnetic field is much stronger than any other part, and that's why we call that as a pole. If one of the pole is north, the other one will be south, because as you can see in geography that north and south are opposite of each other, same like east and west. So if one pole I call north, then the other pole will be south. And the space where the Region where the magnetic field is stronger within the magnet, that's called the pole. So north and south does not make difference to the force which is experienced by the object. And how we can locate this field, how we can locate this or identify this field, for this purpose we can use a compass. Using a compass we can locate this direction of the magnetic field, or plotting a magnetic field lines, that we will discuss next class. How, because this is a full experiment is there, how a plotting magnetic field lines can be plotted. So I'll end the session at the magnetic field. So we started the concept, introduction of a magnetism, that because the atom consists of the charged particle, when these charged particles are moving, it produces a magnetic field, and the atom will behave like a magnet. We call that as an atom as a domain, and if domains are aligned, we call that as a magnetic material. If domains are not aligned, we call non-magnetic. And in a magnetic material, there are two regions where the magnetic field is much stronger than any other part. We call them as a pole. If one is known as a north pole, the other one is known as a south pole of the magnet. And the space around the magnet where its force can be experienced by other magnetic material, we call that as a magnetic field. The pattern of a magnetic field is from north to south, and in next class we will discuss an experiment to plot a magnetic field lines of a bar magnet. Any question related to the class today?
No, sir.
Okay, so I'll end the session and share the recording with you.